You are the pioneers. With your visions, your ideas, and your passion to make things better. And we are the ones who protect you from pitfalls. We are by your side whenever needed as a true fellow. Reliable, pragmatic, realistic. Together we make your product come alive. Imagine you enjoy improvement. Process fellows.
So hello everyone and welcome to our today's webinar called Forces of Cybersecurity Engineering. My name is Alexander Vollner. I work as a consultant for Process Fellows. I'm going to be your moderator for today. You just saw briefly our new company video. I was very tempted to show you, and we already seen that we cover some topics in there. So I think most of you will know us from Automotive SPICE context, but beside that, we also have several other topics what we address. For example, functional safety, but also cybersecurity, as this is the webinar today, and also mechanical SPICE, Scrum, SIAM, project management topics. So we cover many things. What we're gonna offer? Typically, we do some gap analysis, some assessments, so internal assessments as well as external offered assessments. This is one part we offer. The second thing we're gonna do is, we do the classical consulting, let's say. So give you some best practices alongside, but we also do some intense coaching, which means like training on the job. So we really guide you through several topics there. And of course, we also offer trainings. So we offer the official in-text trainings, but as well as our own design trainings in several topics like hardware, mechanic, cybersecurity, functional safety, and of course, our major topic, Automotive SPICE. So I just want to give you a short overview about our next trainings. So we have the roadshow, which is coming up next. This is going to be next Monday. If you want to join, it's for free. And it's about Automotive SPICE 4.0, of course. And the next roadshow would be also in January 22nd, also for free. And we do offer some provisional assessor trainings before you really, let's say, apply the Automotive SPICE 4.0 version. This is Automotive SPICE version 3.1. And the next course would be February 5 until February 9. The course in November is already fully booked. We also do offer the competent assessor training. It's December 4 till December 8. And last but not least, cybersecurity training. You will see some more dates on our website, so feel free to check it out. So before we start, some organizational topics. Please be muted due to the presentation. We have a specific, in German it's called F&A section here, in English Q&A, where you can post your questions in. And I'm gonna then pick the questions and ask them directly, or let's say collect them at the end, and then we're gonna answer them. Please note, this session is gonna be recorded, and the slides gonna be published after on our website, and also on YouTube. So you can also have a more detailed look later. And yeah, let's come to the real topics. And I would like to introduce my colleagues, Florian and Timo, really quick. So let's start off with Florian. So my colleague Florian, he is one of the cybersecurity experts we have at Process Fellows. He's a provisional assessor. His topics are Automotive SPICE, agile methods, project management, and cybersecurity. And he's also one of the authors of our article we wrote for the SU magazine called My Diary for Cybersecurity Implementation. And he's gonna focus more on the requirements part on the presentation. You're gonna the presentation which will follow. Then let's come to the next colleague. I'm sure you know him because he's done several webinars before. Timo Karasch. He's a principal assessor and instructor, and also trainer for mechanical, hardware, cybersecurity, and automotive SPICE. Also the author of My Diary for Cybersecurity Implementation. And yeah, now I'm gonna hand off to my colleagues. And yeah.
Okay. I'm going to take over now presentation mode. Yeah. Hello, everybody. I'm very happy that you joined our today webinar for cybersecurity. And yeah, before we really start, I just want to give you a little bit of background. So what is this webinar really all about? The idea of this webinar really started when we were working with some customers in introduction of cybersecurity. So the implementation in the daily business, working with a lot of engineers, working with management, and yeah, typically when you start to work with this topic like cybersecurity, you learn a lot about many words, many topics that you need to know. And this is where we collected 4 of these topics. So the goals, the controls, requirements, and the threats. And we found out that it might be a little bit tricky for some of them to bring them here in a kind of order. And we found out they are important, very important for cybersecurity. And this is why we call it even forces here of cybersecurity engineering. And this brings us to the idea of this webinar. We pick out these 4 topics. Yeah, as you see here, cybersecurity threats, cybersecurity goals, cybersecurity requirements, cybersecurity controls. When you're sitting in a kind of training, you hear all 4 of them, but you try to map them in your mind or to bring them in a kind of order to see the dependency. And this might be a little bit tricky. And this is why we created this webinar for you to help you a little bit to understand the dependencies here. And so this is as well the basic then for the agenda that we are going to take, because what we will do is we will start with the cybersecurity threats. Means starting from the product point of view, this is where my colleague Florian will take over. We will try to see the product, to analyze the product, to identify potential threats inside of the product. And then based on this idea of threats, we will come to the second part to identify goals for cybersecurity. And then going over to the controls that we selected. And finally, we end up in the cybersecurity requirements. So as you already see in the agenda, it looks a little bit like you're jumping from one side to the other. But I think this is really the problem in cybersecurity, that you very often identify one topic that leads you to a complete other topic. And it's not straightforward, as you typically know from engineering, nor it's really a kind of you're jumping from one side to the other. So our purpose here of this webinar is to really explain this connection between those 4 topics, those 4 forces here. And therefore, we will try to use a very easy example. And maybe I should mention before, I think the example is something everybody knows here, everybody knows from reality. And this webinar should not be to go very deep into technical knowledge, yeah, that you just can start to develop. No, it's more about bringing up this idea of connection here. And therefore, hopefully, you will find it helpful. But now it's my turn to hand over to my colleague. And here, he will start with a product.
Yes, Timo, one organizational thing, I have no option to request control, so you need to click yourself, please. So welcome everybody also from my end. Our example, which we want to use today for illustrational purposes, is an electric tailgate actuator. I think we all are familiar with these kinds of systems. It's just for electrically opening and closing the trunk of a car. And you can also do that either by the button on the trunk itself or by using a remote control as part of your car key normally. This example, which we are using here, is completely made up. So this has nothing to do with any actual system or product. It's just something we as process fellows use as a holistic example, and everything you see here was, invented by us. So it's also, as Timo already explained, the idea is not to be absolutely technically precise in detail, but it's illustrating concepts and the ideas behind. So let us look into the system architecture of such an electric tailgate actuator system. Yeah, so this is a rough system architecture, what we see here. And we see here in yellow the system boundary of our system itself. So within our system, we might have components like an ECU, an antenna, which is used for just receiving and sending signals, maybe an electrical motor, which is manipulating, let's call it a spindle, and this spindle is then again fixed to the tailgate itself, and this tailgate is being opened and closed by the movement of this spindle. Yeah, that would be the first external interface, because the tailgate here is outside of our system boundaries. Besides that, we have a couple of other external interfaces. For example, we will have something like a power supply for the electric energy, a sound actuator, so we make sure our tailgate actuator is making a sound when it's being remotely opened. And a couple of communication interfaces, and this is what we are interested in today. Yeah, so we want to look onto the system from a cybersecurity perspective, and consequently, of course, the communication interfaces are of interest for us here, which are the ones we see here now, exactly. So if we want to handle these from a cybersecurity perspective, then this will mean for us, we have a couple of additional work packages to do here at these points, and to make sure that cybersecurity is properly taken care of when developing this system. To decide if such a system is cybersecurity relevant or not, the respective ISO standard 21434 is giving us this chart here to support a decision. Yeah, you also see here where exactly you can find that. And well, let's just go through this flow chart. Yeah, so first question to be answered is our candidate an electric or electronic item or component? If you can answer this question with no, let's assume we are talking about a tire maybe, then this candidate is not cybersecurity relevant. If it is an electric or electronic component, then we come to the right part. And whenever one of these three questions here is being answered with yes, then we already know we are cybersecurity relevant. Yeah, so let's just go through them by our example. Does our candidate contribute to the safe operation of the vehicle? Well, I think definitely yes, because if our tailgate actuator would malfunction or not work as expected, for example, during driving, this is definitely having an effect onto the safe operation of our vehicle. So here we already know we are cybersecurity relevant. Point number 3 here on the flow chart, does it implement functions which require collection or processing of user-related data? Well, probably the answer here is no. But question number 4, does the candidate implement vehicle functions based on network components? Definitely, again, a yes, because on the page before, we saw that we are going to have an interface to the surrounding car environment too. Yeah, so we now know our system will be a subject of a cybersecurity analysis. And therefore, well, how do we start such an analysis? Typically, the first thing you always do is you collect your assets, which we see here in the second column. For this example here, we just have outlined one of multiple assets. Yeah, so this example is stripped down, it's simplified, and we are just using here this one asset. And this asset is this communication interface between the car key, the radio key, and the antenna of our system. So we will focus on this specific aspect here. We also see here on the left that we do this analysis from the perspective of the stakeholder car user, or let's say driver. You could also do that from the perspectives of other stakeholders, and in real life you also would do so. For example, you would also do such an analysis from the perspective of the OEM itself. Yeah. In terms of cybersecurity properties, you typically, so there is a lot of properties defined. The standard core set is the so-called CIA properties, which we see here also. So again, simplified, yeah. We see here the properties of confidentiality, integrity, and availability. Yeah. So maybe let's shortly explain them. And I just directly read that out from the standard because I think that's the most precise way to define it. Confidentiality means information is not made available to unauthorized parties, and certain people, devices, or processes should be permitted or restricted from seeing data. Yeah, so I simplified a little bit during reading out, but that's the core thing here. Integrity, basically, in my words, means the data must not be changed, or you must know when it has been changed. So you want to make sure that the data actually is as expected. And availability, well, it's pretty self-explaining. Yeah, it means the data is available, or the asset is available as planned, and is basically not unavailable. Yeah. So we also see here some damage scenarios in the next column, and this also helps for illustrating them. For now, I would like to focus on one example again, which is the aspect of integrity here. So today we focus on a scenario where the unexpected opening of our tailgate actuator is done due to a tempered message. What tempering exactly means will be explained in a minute by Timo. But this is a damage scenario we are analyzing now. Yeah? And here we now apply the so-called SFOP scheme. This is a typical scheme for assigning an impact rating to this specific damage scenario here. The letters S, F, O, and P stand for safety, financial, operational, and privacy. Yeah, so this is the specific impact perspective. For example, in our example, if our tailgate should open in an unexpected or unintended way, then this would definitely be have an impact from a safety perspective. That's why we see here a value of 2. Well, financial, not in that way, yeah, not for the car user itself. For example, if you would do this analysis from the perspective of the OEM, you would also have a value greater than 0 in this financial perspective. The big thing here definitely would be operational. Yeah, so if our system is not working properly as expected or as specified, then we would have a big impact in terms of the operational perspective, and privacy is not so much a subject here. So we see here basically this damage scenarios, and I think yeah, in the next step now, we need to investigate. Well, we found here that there is potential impact in terms of damage to our asset under analysis. The question is, how would you potentially attack? Yeah, and this is where I hand over to Timo again.
Yes, Exactly. And yeah, this is the other reason why we are with two presenters today, because now I try to really look from a completely different point of view to what Florian just explained, because he already tried to explain a little bit the damage scenario, this unexpected opening due to a tampered message here, but from the product owner point of view, let's say. What I now try to do is I'm working as a kind of hacker. So means I need all my experience in how can I open a system, how can I course a kind of malfunction, how can I destroy the system. So I'm thinking in a way of misuse case. How can I misuse now the system to cause this kind of damage? And this is described by a so-called threat scenario. So I'm thinking about a threat now for this potential damage on this asset. And this is where I say I will gonna send a tempered message because it may lead to messages at the wrong time. Yeah, it is what you see already. It is typically already very, very close to sending a so-called spoofed message here. So the idea is typically I can send a message that seems to be from someone else, but typically before I can send a message that looks like coming from someone else, first of all, I need to learn about this message. And this is why we concentrated now on this scenario here on the tempered message. Means, okay, we want to take an existing message, a real message between this key that we had and the antenna, and manipulate that we can change, for example, the command in here. And the idea is now, how can we do this? And this is where the hacker comes in place. And one method that is very helpful here is the so-called attack tree. So we're going to use the attack tree. And this means on the very top, we think about what is the goal here, what is the goal of our attack. And you see here, the goal is we want to access the communication. Yeah, we want to go into the communication to change it. And then you try to find different ways to, for example, get access to the communication. We already see here you can try to have direct access to the car somewhere or direct access to the key. But we are talking in cybersecurity at the moment, so it is not really about stealing a car or here doing some forces in breaking the car. No, we want to find access to the message itself that is exchanged here. And how can we do this? And this is where these two possible ways come in place: spoof messages and tempered messages. I think the most efficient way here, sending a message that seems to be from the key, but it's coming from me. But before I know how to do this kind of message, I try to reuse a real existing message and change it the way I want, or send it at a very different moment in time. And to learn about this, one of the ways is the so-called man-in-the-middle attack. Yeah, means the very first time I, the hacker, would listen to an existing message and try to give a different message to the system, and then I know I learn how to change the content of the message here. And by creating a kind of attack tree, I can find out a way to really perform this kind of attack. And this leads then to the so-called attack path. And this is where you see the attack path analysis. From my point of view as a hacker, I try to explain now how do I can realize this attack. I will try to get access to the communication channel that we just saw in the architecture. I will intercept the message flow and then perform the so-called man-in-the-middle attack to temper the existing communication. I have a way to do this. But now for cybersecurity, the idea is how feasible is this idea here? How easy is it to do this? And this leads us to the analysis of this attack path that I just identified here. And this is what we can see here. We selected a method. It's called the attack potential based approach. It's the most popular method typically in analyzing those kind of attack. And this is where you can see we have the attack path over here still. And now we have 5 different topics that we try to address. Because the real problem in cybersecurity is you cannot calculate a probability that something will happen. Here, you have no statistical data about hackers or about how long people need for a kind of attack. No, this is why we have only a kind of likelihood here, because we have not trustable data here. And this is why we try to build up some categories. For example, we try to check the elapsed time. So how long do we think it will take to perform such an attack? And we said, less than 1 week here. Pretty easy to just listen to a message to find the way to use it. Do we need any special knowledge? Here's some expertise here. We think, okay, if you're proficient already here, some deeper knowledge about this, it's enough. What about the knowledge about the item? Oh, this is maybe a little bit tricky because the information about communication channel is already confidential. The window of opportunity. So how often is the system available for us? That's pretty easy because I can try it with every car that is parked somewhere. And do we need some special equipment? Not really. It is already standard because hopefully I'm really allowed to say this out loud, but you can just go in the internet here. You can look for it. You can buy already the BOM here, the bill of materials that you need. You can buy an instruction how to build this on your own. And likelihood means out of those categories, we now try to bring it to values. And this is why this method, this attack potential based approach, got already numbers behind those categories. And this is what you see here. The lower the number is, like here the 0 or the 1, the higher the risk at the end will be, because the more easy is it for me to perform this kind of attack. Only the knowledge about the item here, you see, is something that is not available for everybody. And out of this, we calculate now the value. The sum is 12. And if you look in the attack potential based approach, you can see this means the attack feasibility value is high. So it's very high. That an attacker might use this kind of attack path to perform this kind of attack. And here, as you saw already, Florian presented some numbers. I presented some numbers. Time now for the next step, and I can hand over to our product owner.
Yes, the idea of all of these investigations here is, from a cybersecurity risk management perspective, we want to have a risk value for each of these scenarios. Yeah? And this risk value basically is a combination of those 2 aspects we have explained so far. The one thing which is an impact here is this impact rating. That's what I explained. And this basically expresses what would the amount of impact be in a damage scenario. Yeah. So how serious would this be? The second input would be this attack feasibility rating. So how likely is it that this can be done by someone? Yeah. And in combination of both, this will now lead to a so-called risk value. Yeah. This risk value basically is a combination of those values we see on the left side here. So I try to explain it in a summarized way. You can imagine that you have a matrix, and on the one side you have the impact ratings as an input. On the other side you have the feasibility ratings, and for each combination, this standard from the ISO or from this attack which Timo explained gives you a result. Yes, so let's say for the input combination of 3 and 12, you get this operational result here with the value 5. Yeah, so there's also a color code behind that. That's also not specified by us, but by the standard here. This color code indicates here how critical these risk values are. In our example here, we see, okay, we have at least two values which are critical. Yeah, so the values 4 and 5 are pretty high, and somehow we need to handle these risks. This brings us basically to the next step now. Based on this risk value, we need to take a decision how we want to handle this risk. Yeah, that's what we see here illustrated as a flow chart. And for this handling, basically, there is four alternatives or four options, which is, again, given by the ISO. We see here in the bottom right corner, for each such a threat scenario, you can decide to handle it by avoiding the risk, which would mean that you change something in your system or in the overall scenario where this is not given anymore. So, well, in our example, could be something like, well, we don't do any radio opening of the car anymore. That would mean avoiding. Basically, something we probably do not want to do because we want to have this comfort feature of opening the car from remote. Second one would be reduce the risk. This is what we are going to speak above a little bit more in detail in the next minutes. And the other two options would be sharing and retaining. Sharing would mean that you, for example, for certain kinds of threats, you could share or transfer them by, for example, doing an insurance or something like that, something OEMs do in certain scenarios. And retaining basically is another word for just accepting that this risk is given. Yeah, so we decide here now in our example that we want to reduce this risk. So we want to make this potential attack less likely. And therefore, we will, in consequence, now have to implement certain controls. Yeah, so controls is the next concept from our forces. And the first step of controls would be that we will now invent a security goal. This is a bit similar to functional safety, where they are called safety goals. Yeah, and here it's called security goal. And yeah, for today, this will be our security goal. Trustable signal needs to be ensured by authentication of signal. Back to Timo.
Yes, very good. So here, our next task will be to now really decide which control is the best to reach our goal at the end. And typically what we will do, we will use now or reuse the properties that we already talked about. So we take the integrity now here. You remember the integrity was the one that here was endangered by our attack. And when we take the property of integrity, we already discussed the potential attack that we might have on the integrity. So integrity means we are modifying the data or the code, means configuration files, the firmware itself, the storage, or we modify the messages. And when it's about modifying messages, most companies already have a kind of catalog of controls because it's nothing that is completely new. Here we know already from the history what might work in those cases, what might fit best to our kind of products. And this is why here we in our catalog, we looked and we said, typically what we use to ensure integrity of all our messages is, for example, we will try to use hash and CRC. So a combination of two different topics here. First of all, the hash itself is a kind of digital fingerprint for the input. The CRC is only a method to checking whether we have any errors during the transmission. Means the second one, the CRC, the cyclic redundancy check, it will help us first of all to see whether the message has been sent correct or not, correctly or not. And we have no idea. Maybe it's manipulated or maybe it's broken somewhere in the transfer. We just want to make sure, yes, it's a correct message. And then if we know it's a kind of correct message, we can see, hey, let's use a kind of hash key to see whether it is really coming from the correct sender or not. So this is more or less coming already from a kind of your past system, let's say, means we already have experiences. We might maybe already know how good this might work. But now we identified what control we want to use in our system. And this means we need to implement this kind of control. And this is why here I cannot hand over back to our requirements expert, because implementation is typically something that leads us to requirements.
Exactly. Whenever it comes to implementing a function, it's about specifying it first. Part of our requirement specifications will consequently be cybersecurity requirements. Again, a certain similarity to, for example, functional safety. Basically what we will do with cybersecurity requirements is we are gonna detail the cybersecurity goals, and we will find these kinds of requirements on all levels, basically on all requirements levels. So on the system requirement level, but also on the level of domain requirements, in particular software and hardware requirements. So I would say in 98 to 100% of cases, you will find security requirements for both software and hardware requirements. There is also scenarios where you would even have mechanical requirements, which are cybersecurity requirements. Yeah, for example, if it's just about physically protecting an interface from access by an external party, then so like just lock it from people. Yeah, that would be a simple example of where mechanical requirements are also coming into the game here. What we see here, by the way, is basically a sketch from the process world, from the SPICE models, from the SPICE pumps. Yeah, and here we restricted that to the engineering processes. So what does it mean if we talk about cybersecurity requirements? Let's have a couple of simple examples here. Maybe let's start from the top. Purpose of cybersecurity requirement would be, let us implement a communication protocol which includes some function in terms of hash and CRC combination to protect the integrity of radio communication. Yeah? It's a bit formulated like a customer requirement. And by the way, in the chart before, of course, also customer requirements can be cybersecurity requirements. Yeah? Nowadays, most of the projects actually do have cybersecurity relevance as well. If we transform that into system requirements, then examples for system requirements could look like the four which are given here. Yeah, so system shall ensure that key is sending these two informations. Then system shall be able to check hash and CRC information. And then the software shall read those, and the software shall run these analyses on a hardware security module. Yeah, so we see here on the right as well, these are system components, what we see here, where these requirements are allocated to. And this could be very simple examples of system requirements with a cybersecurity perspective. Transforming that as an example into software requirements, that's what we see here in the bottom part. Software shall read the information on the interface. Software shall compare the hash and the CRC. And then if these checks are okay, the software shall control these open command. Yeah? Here on the right side, we see parts of the software architecture. And these terms which you see here will be illustrated in a bit more detail in the next step by Timo, because now again, we come to the technical implementation of these requirements.
Yeah, exactly. Thanks a lot. So here, I already mentioned the control is very often nothing completely new. This is something what you already used in the past, so you already have a kind of knowledge, or maybe the basic structure. And this is why it might be already possible to identify some software components in this example on the requirements level. And requirements architecture is very often a kind of cycle here that you jump from one side to the other. You identify new elements in architecture, jump back to the requirements. and detail again in the architecture. And this is why for the basic architecture, we reuse what you already saw at the beginning, yeah, the very rough idea of what the system looks like. And this is what I try to show here in a threat model. So I do not present now the complete threat model for the complete system that we see here. No, we want to concentrate now on a very easy topic. So what you see already in this dotted line here is the control unit. It's the control unit boundary. So we mean everything that happens inside is something we can control on our own. You know, this is something we can handle, we can implement. But what we know is, we saw it at the beginning, we have some channels to the outside. And this is where you see already the radio key here that is giving this signal to open. This is received here by the antenna. This is what you saw in the architecture at the beginning already. We have now this request open that is typically done by the control software, and the control software will now give the request open to the actuator here somewhere outside. This is where you know we have the spindle here, and we have the actuator outside. The threat model is a model or a kind of view, I would say, for the architecture, a kind of additional view that is very helpful for the cybersecurity context, because it's not only simplifying what happens inside of your architecture, even showing you some dynamics, there's some flows inside of the architecture. No, it helps you now even to address those topics of cybersecurity that we already discussed. And this is where we start with a threat, because the threat was the tempering here, the tempered signal. And this is why we said we just want to intercept this signal to open the tailgate and try to temper this message. You could as well say, no, this is where we spoof the message, here send another, or we want to block the send of message. So the threat model allows us to demonstrate a little bit where this attack takes place. And this means all the flow after this attack now is not trustable anymore for us. And this is why we need now a way to react on this here wrong or changed message. And this is where our control again comes in place, because in the threat model we can as well put now the control that we selected. And here we try to explain it here, just the basic idea here. So means the information from the antenna is not going directly to the control software. No, we will have, we decided to have a security onboard communication module here, and as well a crypto service manager. They're typically located here on the basic software layer, means we will ensure the communication, or we will take the communication here and a specific module that will be developed then in the software. And this is where we do the hash compare to see whether the send key from the radio key is correct. Here, the information is trustable, and we can do as well the CRC check to see whether it is a correct message, it's complete. And before we really start this control, this open request, we have now the crypto service manager. He's doing the communication inside of the layer. Means here, if the result is trustable, then we can give it to the next higher layer, and at the end it will reach the control software, and here it will only do this request for open when we are in when we received a trustable information here, a trustable message. This is a very rough idea maybe from the threat model, but it already shows you what is possible. So it's a kind of view of the architecture. It shows you already to highlight where the threats are, and it shows you as well to highlight where the control will be implemented. And this is why this kind of threat model typically is used even on different levels, very rough, or comparable to what you see already during the first TARA, during the threat analysis and risk assessment. You will reuse it on system level, and you can even go down now on software and hardware level to really explain this kind of implementation, what we already mentioned here. And that's it on the left side of the V already here, because everything that follows now is up to the developers at the end. We, from our point of view of requirements, what Florian explained, and I, from the point of view of architecture, we already did our job, and now it's part of the implementation of the developers here. But finally, we would like to already show you that those results will be reused as well on the right side of the V, and this is where testing comes in place. And this means we collect now the most important topics that we already presented to you here in this webinar, and these were the cybersecurity goals that Florian explained, the threat scenario that I explained, and the cybersecurity requirement that you saw on the page. And here, giving you examples, cybersecurity goals, they will be reused in the cybersecurity validation, means we will try to attack the system to compromise the goals. Here, we will try to work as a real attacker to see whether goal is ensured, or maybe we find a kind of vulnerability for this kind of goal. We will reuse the threat scenarios again. And for example, we can use it for a kind of interface testing. We can check the effectiveness of the control by sending a tempered message. Yeah? So we send a message, a tempered message, and we can see whether our control is reacting here, and so it works efficiently or not. And last but not least, the requirements. This is typical verification, what you know already. We can check the correct implementation of the control. And this again shows a little bit here why this idea of the threat scenario is helpful, because a lot of information that was in this kind of picture here will help you already or give you a lot of information that you can use for testing here. Bringing us to here, conclusion, last but not least. So conclusion. So what we have seen in here in this webinar, and what we found out during the work in the project was, first of all, I need to, that it works again. Okay, the development challenge might not be that big. What does it mean? It is not that all the developers need to learn some completely new task here within their development work. They know already working with architecture or with requirements, they know about implementation, and even a lot of controls are already known. Here, it's we talk about activities that are very often already well established in the companies. I think the main challenge really is to understand these dependencies in the development task. Because when you're just sitting somewhere in a training and you hear something about controls, requirements, and so on, afterwards you're more confused than really knowing about this. And this is why our idea was to bring you a little bit closer to the idea behind to those dependencies. And this is why here, finally, at the conclusion, we try to show you again what we just discussed. So we started with a product to know what our product is, and we will identify threats and here the analysis and the rating, the goals, the controls, requirements, and the threat models, everything based on these assets here. So we talk about the assets first. It's part of this TARA, the threat analysis and risk assessment, that we will identify the assets, because the threats here, they will attack the assets. The assets is something that you want to protect, that is valuable for you. So threats are based on the attacks already. And the analysis was what we showed you already, how big is the impact on the assets on the one side and how feasible is the attack on the other side. We use this analysis, the analysis results, to identify the goals, what we showed you. And to implement a kind of goal or to reach a kind of goal, we selected the controls. And we broke it down into the requirements, the requirement on system level, but as well down to software and hardware level. And what you see again is this is a kind of central method here, the threat model, because it helps you with all of these tasks, or to connect all of these tasks. It helps us already to identify the threat or to highlight the threat in the model. It helps us for analyzing the threats or identification where the control will be placed inside of the system, and here even leads as a kind of basic for deriving the requirements later. And then you see verification, validation. This was based on those ideas of here what we come from the threat model and the requirements here. Last sentence from my side, and then hopefully we can have some questions here. So we hope that this presentation, this webinar, helped you a little bit to understand those dependencies between those topics. And here, maybe you can reuse this kind of overview here for better understanding how all these different topics, and especially these 4 forces of cybersecurity, will work together. I will hand back to our moderator.
All right. First of all, thank you very much, Florian and Timo, for this very interesting presentation you just showed us. We already had one question from the audience, but this was at the very beginning of the session, was the question about competent trainings in the near future by Lisa Erich. I just comment you the next trainings, and you can just check it out on the website. Do we have some more questions, especially for the cybersecurity topic? Because at least I have some. So maybe I start off with a question. As we all know, we have the Automotive SPICE for cybersecurity model, and as well we have the official standard. Your presentation was referring to which of them, or was this a mix?
No, it's mainly the idea. The idea of this was really talking about the ISO 21434, and there is a main difference really because when you check the Automotive SPICE of cybersecurity, then you will see that the goals will first lead to the requirements here, because you have a requirement topic, and then you come to the controls, because the controls are mainly connected with the architecture. But the approach that is mentioned in the 21434, this is what we pick here as well, is more common. I would say that you first identify controls because it's nothing completely new, and then you define the requirements for implementation of controls.
Thank you very much. We have one question from Antonia. I'm going to read it out loud.
Yes.
Oh. Or you can also say it directly, Antonia. It's up to you.
Okay. Thank you very much. So yes, this was one question which I have heard from other assessors, and I wanted to hear your opinion. If there are elements out of functional safety-related practices like fault tree analysis or hazard analysis, really input for the TARA, so to find more assets eventually based on these safety aspects.
Maybe this topic came up because of Automotive SPICE for cybersecurity, yes. Because in this model, it is named very often. You can use something like FMEA, HARA, or FTA, but no, here it is something completely different. What I would say, knowledge about FMEA and HARA is very, very helpful, because the main idea of how this method works, will help you as well when performing the TARA, the threat analysis and risk assessment, because it's the same approach, the same idea behind, but it's different, and this is why it's not helpful. I would say it's nothing that you need to use there. But there is a connection between functional safety and the cybersecurity. Maybe this is something we should point out again, because one important topic, one important asset are always the safety goals here, because you saw the slide with the SFOP here, safety, financial, operational privacy, that might be attacked, and safety is an important issue there. And this is why most of attackers try to attack really the safety. And this is why the results of HARA will be important for creation of Tara.
Thank you.
Okay, any more questions? I think that's it. We covered everything. And yeah, thank you very much for this webinar. Oh no, we have one last question here, last minute one. Let me quickly jump to the chat. This question comes by Hassan Tarek. What kind of approach should we have against ideas of dissenters? Dissenters. Yeah, you can also read it in the chat.
Yeah.
Can we ask for a bit of a more detailed explanation what this is? Because I don't get the term dissenters, I must admit. So maybe you can explain a bit more, Hassan? You can also write it down in the chat, yeah?
Or you can also unmute yourself. Yeah.
Yes, actually, I want to ask about different ideas. I think dissenters. If someone can find any different trade scenario or something like this.
Okay, yeah. So means you start at the beginning. You know, there might be a kind of damage, and then talking about different ways to attack. Is it right? What do you mean?
Yes, I mean something like this. I couldn't join in the beginning of the meeting, so that is why I asked this question.
Yeah. Okay. So yeah, what we tried to do in this presentation was we gave the example. I just jumped to the slide back. We try to use the attack tree here. So it means we know what kind of damage we were heading for, and with the threat scenario, we try to we use the attack tree analysis here, and it might be that you have more than one way, and then you can compare. You can even see how feasible what way of attack might be, what attack the feasibility of different attack path, and then typically most of them will lead even to the same goal here and to the same control at the end.
Okay, that's clear. Thanks.
Thank you also for your good questions. And I would say we can close the session. Thanks again, Florian and Timo.
And
thank you. See you at the next webinar.
Okay, thank you.
Thank you very much.
Thank you. Bye-bye.
Bye.
You are the pioneers. With your visions, your ideas, and your passion to make things better. And we are the ones who protect you from pitfalls. We are by your side whenever needed as a true fellow. Reliable, pragmatic, realistic. Together we make your product come alive. Imagine you enjoy improvement. Process Fellows.